Dear students, today I'll discuss with you some important MCQ from the chapter Solid State. The first question is the correct statement regarding the defects in crystalline solids is what? Out of the choices, which one is the correct? So choice A is the correct. Frankel defect is a dislocation defect. Dislocation means changing the position. Okay, changing the position is the known as dislocation. So what is Frankel defect? When cation shifts from lattice to interstitial sites, the defect is called the Frankel defect. Again I am repeating, what is Frankel defect? When cation shifts from the lattice to interstitial site, the defect is called the Frankel defect. Okay. Next question. If NaCl, question second, if NaCl is doped with 10 to the power minus 4 mole of strontium chloride, the concentration of cation vacancies will be what? So this is your Avogadro's number. Okay. So you see how to do this. The strontium doped. What is doping? Doping means adding. Doping means adding. What other metals or cations? Other, it is known as impurities. Adding of impurities. So say you may add the strontium chloride adding, it is doping with NaCl. If NaCl is added with strontium chloride, then it is known as also doping. So adding to the purity, if we add another compound, then it is known as doping. Okay. So here what is the thing? For each strontium ion, see, for each strontium ion introduced, one cation vacancy is created. One cation vacancy is created. Okay? Because two Na plus ions are removed and one vacant site is occupied by strontium plus. Okay? So if two Na plus ions are removed, one position is placed by Sr plus 2. Okay. So Sr strontium chloride, you see strontium chloride doped per mole of NaCl, per mole of NaCl is equal to 10 to the power minus 4 by 100. So this is equal to 10 to the power minus 6 mole. Okay. So this is equal to 10 to the minus 6 multiplied per mole 6.02 multiplied 10 to the power 23 strontium plus 2 ions. Okay. So this is equal to 6.02 multiplied 10 to the power how much? 6, this is 17 strontium plus 2 ions. Okay. So hence concentration of cation vacancy is how much? 6.02 multiplied 10 to the power 17 more. Okay. So which one is correct? This D is the correct answer. Okay. Next. Question number 3. The crystal with metal deficiency defect is what? the crystal with metal deficiency defect is what? Which one? So out of the choices, iron oxide, it is the correct answer. In FEO, question number 3. In FEO, this is your ferrous oxide. Okay, ferrous oxide. In FEO, some Fe may be present as +2 or some may be present as +3. Okay, so 2 Fe plus 3 is equivalent to 3 Fe plus 2. Okay, hence FeO should have metal deficiency defect. Okay, it is the balance charge, balancing the charges. Okay, so question number 3, choice B is the correct answer. Next, in experimentally it was found that a metal oxide has formula M0.980 minus metal M is present as M+2 and M+3 on its oxide. Fraction of the metal which exists as M+3 would be what? See, question number 4. How to do? You see, the formula M0.980 means what? It means if there are 100 oxide atoms, okay, present in the oxide ion, so 98 metal atoms are there. That is the meaning of M0.980. Okay, if 100 oxide atoms are there, 98 metal atoms are there. Okay, so out of the 98, some are M+2 and some are M+3. Okay, out of the 98, some are +2 and some are +3. Okay, suppose M+3 is equal to X. Okay, suppose M+3 is X, then M+2 is how much? 98 minus X. Okay, now we have to balance the charge. So total charge of X multiplied +3 plus 98 minus X multiplied +2 is equal to 100 multiplied 2. This is what? Oxide. This is oxide. So 100 multiplied 2. So total charge of the metal is equal to total charge of the oxide. Okay, so by solving this, X is equal to your 200 minus 196 is equal to 4. Okay, so therefore M+3 is equal to 4 by 98 multiplied 100, its percentage is equal to 4.08%. 4.08%. So the answer is C, 4.08%. Okay, next, which type of defect has the presence of cations in the interstitial sites? Which type of defect has the presence of cations in the interstitial sites? So choice C is the correct answer, Frankel defect. What is Frankel defect? In the first question I repeated, when cation shifts from the lattice to interstitial site, the defect is called Frankel defect. Okay, so choice C is the correct answer. Again I am repeating one. You see first question, how many defects are there and how many voids are there? there are two types of voids. You see, voids, two types of voids. Two types of voids. One is tetrahedral void, other is octahedral void. Okay, one is tetrahedral void, other is octahedral void. How these are obtaining? By the three-dimensional arrangement. Okay, three-dimensional arrangement. I will show you one diagram. By observing this diagram, you can understand clearly. You see, this is the diagram. Okay, you see, this is the diagram. You see, in the diagram here, what you observe? This is the first layer, A, then this is also A type of molecules are there. So this is first layer. In the first layer, we are getting here A. Okay, so the triangles are towards the downward. Okay, to cover this, we are putting another spheres. To cover this, we are putting another spheres of the same category. In this way, we are closing these voids. These are the voids. Okay, we are closing these voids. So this type of void, see, A is closed with four spheres. One layer, first layer, three spheres are there. To the top, another sphere is placed. As it is closed by 4, then it is known as tetrahedral void. Understand? But if you consider this case, the D, here is written as D. You see, D, small d's are written. When you put another spheres in another row, then we are not covering such type of voids. The D voids we are not covering. To cover this such type of D voids, again we have put another spheres on this top, that is third layer or third floor. Okay, so when you put another layer on this third, but it is covered by one side. To cover the another side, we have to put another spheres. So totally 6 spheres it needed to cover this such type of voids. Therefore, such type the D voids are known as the octahedral voids. Do you understand? Again I am repeating. You see, these are one type of voids, A. And these voids are covered by 4 spheres. But to cover such type of spheres, we need 4 layers. 4 layers means it requires 6 spheres. Okay, first layer, second layer, third layer, fourth layer. Okay, therefore these are known as the octahedral voids. Okay, students.